Hello, pre-algebra students. We're really going to start having some fun with triangles today because we're introducing the Pythagorean Theorem. So we've been using square roots, and now we're going to apply that knowledge to using the Pythagorean Theorem to solve problems. Let's get started. The bridge in this picture is called the William H. Harsha Bridge. It's a cable-stayed bridge that spans the Ohio River between Maysville, Kentucky and Aberdeen, Ohio. You'll notice that the cables form a triangle here. So the question I have is, how can we use the Pythagorean theorem to find the length of this side of the triangle? All right triangles have three sides, of course, because they're triangles. The hypotenuse is this line right here. The hypotenuse is the line that is directly across or directly opposite from the right angle. That's always called the hypotenuse. These two sides right here, they're called the legs. And they're the sides that form the right angle. So the lengths of the legs and the length of the hypotenuse of a right triangle are related by what we call the Pythagorean theorem. And here it is, finally. I keep talking about it, but here's the Pythagorean theorem. For any right triangle, the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. So in the right triangle I've drawn here, the legs are in blue, and their lengths are labeled A and B. The hypotenuse is in red, and its length is C. So, to calculate the length of C, we would simply take A squared plus B squared to equal C squared. So, back to our bridge. Let's say we know the length of the legs. Leg A is 212 feet, and leg B is 478 feet. So to find the length to the nearest foot of the red cable, the hypotenuse, or C, we're going to use the Pythagorean theorem. That means A squared plus B squared equals C squared. So we have 212 squared plus 478 squared equaling C squared. Of course you may use your calculator for this because that's going to be a tricky one to do by hand. So go ahead and punch that in and you'll get, let's give ourselves some space to work here, and you'll get, let's see, 44,944 plus 228,484 equaling C squared. All right, so when we add those two together, we get 273,428 equaling C squared. Let's take the square root of each of those to solve for C. And that will give us approximately 523 feet. So the length of the cable is approximately, though not exactly because we don't have a perfect square here, but it is approximately 523 feet. Now what if we know the length of the hypotenuse and the length of a leg, and we need to find the length of another leg? Let's try that. Let's imagine we have a triangle that looks like this. We know that B equals 10. We know that C equals 12, but we don't know what A equals. So let's go ahead and set up our formula. We know that A squared plus B squared equals C squared. Let's plug in what we know. A squared plus 10 squared equals 12 squared. So we have A squared plus 100 equaling 144. Let's get A by itself by subtracting 100 from each side, giving us 44, A squared equaling 44. Find the square root of each side, and A will equal the square root of 44, which we can simplify by finding the greatest perfect square, and that's going to be 4 times 11. So we're factoring finding the greatest perfect square, and that's going to give us a final answer of 2 times the square root of 11. So the unknown length A is 2 times the square root of 11. Here's your checkpoint. For each of these 3 problems, find the unknown length and write your answer in simplest form. So if you're getting a radical for your answer, make sure that you're writing that in simplest form. Press pause while you work. There are more examples after this checkpoint. In the last part of this section, we're going to talk about the converse of the Pythagorean theorem. No, I don't mean this kind of converse. I mean that we can use the Pythagorean theorem in an if-then way. Let me show you what I mean. We would say in the theorem that if a triangle is a right triangle, so a triangle with a right angle, then a squared plus b squared equals c squared. That is the if it is a right triangle, then a squared plus b squared equals c squared. The converse of this is that we simply reverse it. We're going to reverse the 2 parts of the statement. So the converse would be if a squared plus b squared equals c squared, then you have a right triangle. So although not all converses of true statements are true, the converse of the Pythagorean theorem is true. So if we switch the if-then relationship, it's still true. So we can use this idea to determine whether a triangle is a right triangle. Let me show you what I mean by that. Let's say we're given these measurements for a triangle. A equals 3, B equals 5, and C equals 7. So let's evaluate this to see if it works in the Pythagorean theorem. We'll simply plug in the values, substitute the values. So we have 3 squared plus 5 squared equals 7 squared. Okay, well 3 squared is 9, 5 squared is 25, and 7 squared is 49. Well, 9 plus 25 is 34, and that is not equal to 49. So this is not a right triangle. And we know that because in our if-then statement, we don't come out to a correct answer. If a squared plus b squared equals c squared, then it's a right triangle. But since that's not true, this is not a right triangle. Let's look at another example. In this example, a equals 15, b equals 8, and c equals 17. So 15 squared plus 8 squared equals 17 squared. 15 squared is 225, 8 squared is 64, and 17 squared is 289. 225 plus 64 equals 289, which is equal to 289. So in this case, our if-then statement works. If a squared plus b squared equals c squared, then we have a right triangle. So in this case, where a equals 15, b equals 8, and c equals 17, we do indeed have a right triangle. This brings us to the end of our section on the Pythagorean theorem. I'll see you tomorrow to do some practice problems with this fun new idea.